Hi, I want you guys to take a look at the following question. Now, the first question is on how do you represent the sales data for quarter one? It's actually relatively straightforward. You just have to create a matrix that contains all the elements mentioned in the text above. So you have 150 laptops, 200 tablets, 300 smartphones, 100 handphone for North. For South, we have 180 laptop, 220 tablets, 320 smartphone, and 120 headphone. And for East, 170 laptop, 210 tablets, 310 smartphone, and 110 headphone. Now do the same thing for quarter two. 160 laptop for North, 210 tablet, 310, 110. For South, 110 laptop, 230 tablets, 330 smartphone, 130 headphone, 180 laptops, 220 tablets, 320 smartphone, 120 headphone. The order of the matrix is simply the number of rows and number of columns. And we know number of rows, in this case, we have 3 rows, we have 4 columns. So the dimension or the order of the matrix is 3 by 4. Total number of elements of the matrix is simply 3 multiplied by 4 equal to 12. You must be wondering, why do I say this is a challenging question when it seems pretty obvious? One thing I want to point out for you here is that right now we are kind of having two matrices for quarter one and quarter two. Can you think of a way how we can represent the products, the region, and the quarters in one matrix instead of just two matrices? Let me repeat again. How can we have these two matrices represented by one matrix instead? In other words, we have region, we have quarters, and we have the products. How can we represent all of them in one single matrix? When you have a 2D matrix, you have the rows corresponding to the region and the columns representing the products. Now, if you want to add another quarters, you can actually add one more dimension to the matrix, meaning that instead of having a 2-dimensional matrix, now you have a 3-dimensional matrix. You can think of it as a square versus a cube. So now you have one more dimension, and the actual dimension is the quarter. From O level, it is very extremely unlikely that you'll be tested on anything beyond a 2-dimensional matrix. This example is just to let you have understanding that matrices are not necessarily just 2-dimensional. It can be definitely 3-dimensional. And if you move on to do complex mathematics, it can be even higher dimensional than 3-dimensional matrix. In computers, graphic, and animation, 4x4 matrices are often used to represent transformations in 3D space. The actual dimension, called the 4th dimension, represent operations such as perspective projection that allow 3D objects to be projected onto a 2D screen. This makes 4D matrices fundamental in creating realistic graphics in movies, games, and even simulations. As again, this is just for your information, and anything beyond 2D dimension